All right, for what we have in Aleks for section 2.5, okay, we have in the first problem, we're looking at graphing all horizontal and vertical asymptotes of the function. And we have, first of all, we have f of x is equal to negative 2 over x plus 5. And we have in the setup, okay, so looking for the vertical asymptotes, if there are any, okay, now we have negative 2 over x plus 5, okay, and this function is already in simplest form, okay, and we have, in this case, all right, so we have for the domain now technically x plus 5 cannot be 0 for the function to be defined, okay, and we have that x cannot be equal to negative 5, okay, and for what we have in this particular case, all right, we have the factor from which negative 5 originates, okay, comes from the denominator, which we have at x plus 5. And since x plus 5 is not a factor of the numerator, okay, the factor, since it remains, signifies that the exclusion from the domain is going to become a vertical asymptote. Okay. And so in this case, we have for the vertical asymptote, okay, this will be at x is equal to negative 5. Now, in terms of what we have in the determination of the horizontal asymptote, now again, we have in comparing degrees, okay, we have for the degree of the numerator, we have that n is equal to 0 since we have no x term. And for what we have in the case of the denominator, okay, we have higher order term, we have an x which is of first degree. So we have the m is equal to 1. And we have from the relation in comparing n to m, we have the n is less than m. And if the degree in the numerator is less than what is in the denominator, we're going to have in this case a horizontal asymptote whereupon we have y is equal to 0. And so taking what we have, okay, so we have for the vertical asymptote, we have, again, have x is equal to negative 5. And for what we have in the horizontal asymptote, we have that y is equal to 0. And so checking what we have here. And the result is correct. Okay, for what we have in the second problem, we're still looking at vertical and horizontal asymptotes. Now, for the denominator, for the function f of x to be defined, you know, this cannot be 0 in value. So looking at the exclusion we have from x, it's going to follow that for x cannot be equal to negative 7/2. And since negative 2x minus 7 is not a factor of the numerator, okay, this expression is already in simplest form. So we'll have a vertical asymptote where this exclusion is going to be, in this case, where the vertical asymptote, we have x is equal to negative 7/2. And going back to what we have in the layout for the horizontal asymptote, okay, so we have, in the case of the numerator, we have the n is equal to 1. Likewise, the higher order term we have to be first degree in x. So we have, m is also equal to 1. And we have in the layout, okay, we have the n is equal to m. And for the horizontal asymptote, we want to have taken the ratio of the highest order terms. We have the higher order terms have negative 6x over negative 2x. And the horizontal asymptote becomes y is equal to 3. Okay, so lining up what we have here. Okay, so we have for the vertical asymptote, you have negative 7/2, so that's going to be negative 3.5. And for what we have in the case of the horizontal asymptote, we had that y is equal to 3. So just pressing, okay, and checking. And the result is correct. Okay, for what we have in item number 3, Okay, again, looking for vertical and horizontal asymptotes. Now again, we have in the denominator, we cannot have 2x squared minus 2 to be 0 for f of x to be defined. Okay, and say if I factor, so 2 times the quantity of x squared minus 1 cannot be 0. Here we have the difference of squares. And looking at what we have with the x factors. Okay, so we have that x plus 1 cannot be 0, and that x minus 1 cannot be 0. So we have that x cannot be negative 1. We also had that x cannot be equal to positive 1. So in the case of the vertical asymptotes, we're going to have a couple of these. Since 2x squared minus 2 is not a factor of the numerator, the exclusions from the domain will be the vertical asymptotes. And again, looking at what we have in the degree comparisons. So you have in the numerator, you have n is equal to 0, and the degree in x in the denominator, okay, is going to be at 2. And for what we have in the relation, we have that n is less than m, and anytime the degree in the numerator is less than what we have in the denominator, we have a horizontal asymptote, which would be the x-axis, where we have that y is equal to 0. Okay, so in checking out what we have, so we have with our vertical asymptotes, we have x cannot be negative 1, x cannot be positive 1, and so we have, with our vertical asymptotes, have x equal to negative 1, x equal to 1. So again, these are exclusions from the domain of f of x. So these boundaries signify that we cannot have the function to allow the values of x at negative and positive 1. And again, for the horizontal asymptote, we have y is equal to 0, and checking out, and we had the result to be correct. Okay, for what we have in the fourth problem, okay, now we're looking at graphing the function. So just sort of expand. Okay, it says to graph the function, draw the horizontal and vertical asymptotes where they exist, and plot at least 2 points on each piece of the graph, and then click on the graph icon. So we have with our function, so we have f of x is equal to negative 6 all over x plus 3. So you have in the layout on this one. Okay, so we have that for the function to be defined, again, negative x plus 3 cannot be 0. And we have that negative x cannot be negative 3. And changing the signs, we have that x cannot be equal to 3. And since negative x plus 3 is not a factor of negative 6, okay, we have our vertical asymptote at x is equal to 3. And where the horizontal asymptote comes in, the degree of the numerator is 0. The denominator has a degree of 1. And so we have in the relation, we have that n is less than m. And so there's going to be a horizontal asymptote once again at y is equal to 0. So we have with the asymptotes. Again, so we have y is equal to 0. We have that x is equal to 3. And looking at plotting points throughout. Okay, so and we'll just have in the mix. Okay, so we'll just have with values of x. We have y is equal to negative 6 over negative x plus 3. All right. So we have this particular case, right? So I'm just going to pick out some values. Okay, so if I have like x is equal to 2, and we have for y, we have negative 6 over the negative of 2 plus 3. So you would have as an ordered pair, you would have 2, negative 6. And if I go with, say you have, say the x value is at 1, then we have negative 6 over the negative of 1 plus 3. So you have negative 6 over 2. So that would be at negative 3. So we come out to 1, negative 3. Okay. And if I were to go out even further, okay, so you have, if I go to, let's say, it says plot at least 2 points on the other side, okay, or each side of the vertical axis, so you have 2 points to the left. And if I go 2 points to the right, so if I go to x equal to 4, we have negative 6 over the negative of 4 plus 3. So I have negative 6 over negative 1, which will come out to positive 6. So we have 4, 6. Now if I go with x at 5, so we have negative 6 over the negative of 5 plus 3. So I have negative 6 over negative 2, which will be a positive 3. And we have with the order pair, so I end up at 5, 3. Okay, so looking at what we have and plotting points. Okay. All right, so we have just for the locations. Okay, so we have for taking what we have and plotting points. Okay, so we have 2, negative 6, plot point. And if we go with 1, oops, negative 3, plot point. And we have, say, next in line. Okay, so if I have 4 and 6, plot point. And in the case of what we have for the next, in case we have 5 and 3, plot point. Okay, and so just taking what we have now, so with the connection and checking out, the result is correct.